Hello, Leon. It's your Zayde, Mason. I'm here today to read you Pythagorean Theorem for babies. This is for you. This is a ball. This is a red ball. It has no corners and it has no sides. It's round. See? No corners, no sides, because it's a ball and it's round. This is a square. Aha! We haven't talked about squares before. See? This square has 4 corners. 1, 2, 3, 4 corners and 4 sides. 1, 2, 3, 4 sides. It's a square. It's a red square. Squares can be any size long as long as the sides and corners are the same. So it has to have 4 corners and all 4 sides have to be exactly the same length. See? 4 different squares, 4 different sizes, but they're all exactly the same width as height. This big square is made up of 9 smaller squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's one big square. And it's still the same width as it is height. Ooh, a blue square. Except this isn't a square, this is a rectangle. It has 4 corners that are the same. See, 1, 2, 3, 4 corners. But the sides are different. See how the height is slightly shorter than the width. So that makes it a rectangle instead of a square. And this rectangle is blue. But the rectangle can be broken down into squares. And in this case, this rectangle has been broken down into 12 squares. Ooh, a triangle. So this is a triangle. This is a purple triangle. See? And there are many different kinds of triangles. See that? They have different shapes, but what's the same about them? They all have 3 sides and 3 corners. But in some cases, the corners aren't the same. I think we're about to talk about that, but we'll see. Nope. So yeah, 3 different kinds of triangles. They're different colors, yellow, blue, and red. And each of the different types of triangles is a different kind because the corners aren't all the same. In this one, 2 of the corners are the same. In this one, and none of the corners are the same. In this one, none of them are the same either. Okay. To square a side of a triangle is to make a square with the same size as that side. So here we've made a square with the same size as the side of this yellow triangle. All 4 sides of the square are the same, and it's blue. And here this one is a different size. So this one has a red square, and it has a different size than the blue square. And then this one has the same sides with height and width equal to the length of that side of the triangle. So we have squared the side of a triangle. And each one of those squares, you can count the red blocks and the green blocks and the blue blocks, and we've broken them all down into a number of different squares of the same size, and you can count all of the number of different squares in each one of the blocks. So each block has a different number of squares in it. This one has 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So it has 25 squares in it. And this one has 9, and this one has 16. And look, 9 plus 16 is equal to 25. And you're going to learn that soon. The number of red and green blocks is the same as the number of blue blocks. So look, if you stack up all of the red and green blocks together, it makes exactly the same size square as the blue blocks. So 9 plus 16 is 25. And the Pythagorean Theorem says that when you do this, it's the same for every triangle, no matter how big the triangle, at least for a right triangle. And a right triangle means that at least one of the corners is exactly 90 degrees. We call that orthogonal. And there's another way to prove this. So if you start with a square on the triangle's longest side, see that's the longest side, that's the blue square we were talking about, then each side of the blue square is the same size as the longest side of the yellow side of the triangle. So if we took 4 exact copies of that triangle and we put them around the edge of that blue square that we put on the long edge, they'll all fit perfectly and make a larger square all together. See that? There's actually 2 squares, one on the inside and one that's made up with the blue square plus the yellow triangles. If you cut the blue square into 4 equal triangles, the blue and yellow triangles are the same size. Hey, look at that! The blue triangles and the yellow triangles are the same size. And if you swap the 2 blue triangles with the bottom blue triangles, then the size of the blue area has not changed. So all we've done is traded the blue and yellow triangles from the top to the bottom, and we still got the same size square as before. The original green square fits perfectly over this part of the triangle. So, see that? Okay. And the original red square fits into that area, over that part of the blue area. And all together, that makes up the Pythagorean Theorem. Now you've just proved the Pythagorean Theorem for babies. And this is for you. All right, Leon. Well, that's Pythagorean Theorem for babies. And I hope you've enjoyed this. I love you very much. And I will talk about another book very soon. Okay? Bye for now, Leon.